Okay, good morning, Mr. Trutna here. Today is Monday morning, April 27th, 2020. I am coming to you live from my living room. And what we're going to be doing today is we're going to be spending some time on a brand new formula that you guys have never done before. So this will be new to you. It is called the quadratic formula. And what we're going to do though today is we're going to emphasize a part of the quadratic formula, which is what is called the discriminant. Okay, so let's go ahead and jump right into this right here, and let's talk about what the quadratic formula is. So there is a formula in math. It is probably one of the more well-known formulas, which is called the quadratic formula, and I'm going to tell you what it is in a second. But the quadratic formula is, what you do is it's used to solve a quadratic equation. Okay? So last week we worked on how to solve a quadratic equation by completing the square. Today we're going to learn on how to solve an equation. Well, we're not really going to be solving today, but I'm going to introduce to you the quadratic formula. Okay, now for point of interest, if you guys aren't quite sure what I mean by a quadratic equation, remember a quadratic equation by definition is any equation with two as the largest exponent. As the largest exponent. So if you see any equation where the largest exponent is 2, that is what is known as a quadratic equation. The quadratic formula is a formula, it's a strategy, and it's a formula that lets you solve quadratic equations. Okay, so for instance, x to the second power plus 7x minus 11 equals 0. That would be a quadratic equation. Why? Because what's the largest exponent? It's a 2. So what's one method that we could use if I said solve this equation? You could use this formula called the quadratic formula to tell me what the answer or answers are to this equation here. Okay, but first of all, let's go over, before we really dive into this, let me show you what the quadratic formula is. And when I show it to you the very first time, most students panic because it looks like a relatively complicated formula, but rest assured everybody that it's actually pretty straightforward when you start using it, and once you become comfortable with it, the intimidation factor will go way down. So the quadratic formula is this formula here. It's x equals negative b plus or minus the square root of b squared minus 4 times a times c, and that whole thing, b squared minus 4 times a times c, is all in the square root symbol, all divided by 2a. So that right there is what is known as the quadratic formula. Okay, x equals negative b plus or minus square root b squared minus 4ac, all divided by 2a. X equals, wait, I feel like there's a song coming on here. X equals negative b plus or minus the square root b squared minus 4ac, all divided by 2a. Wow, I feel like I just made that up. That'll be a top 1 gazillion hit, I'm sure of it there. But that is the quadratic formula right there. Okay, we use this formula to solve quadratic equations. Quadratic equations is any equation with 2 as the largest exponent. Today, though, we're just going to emphasize what is known as the discriminant. Okay? The discriminant it's a part of the quadratic formula. And the discriminant is this part right here. B squared minus 4 times A times C. So that part right there is what is known as the discriminant. Okay, so what is the discriminant? Well, the discriminant is the B squared minus 4 times A times C part of the quadratic formula. It's a special piece of the quadratic formula here. All right, and today we're going to be focusing on just the discriminant, just the B squared minus 4 times A times C part of the quadratic formula, which is known as the discriminant. Okay, so why are we focusing on this, you wonder? Well, here is why. The discriminant tells you something about the solutions. So the discriminant, which once again is B squared minus 4 times A times C, it tells you if the equation, the quadratic equation, so it tells you if the quadratic equation will have two real solutions or one real solution or an imaginary solution. Okay, so that's what the discriminant tells us. It tells us if my equation, it doesn't tell us what the answer is, but it gives us like a snapshot or a clue, and it tells us if we're going to have two real solutions for answers to my equation, or if we're going to have one real solution for answers to my equation, or if we're going to have an imaginary solution in my equation. Okay, so how do you know this? Here is how. So if B squared minus 4 times A times C, now once again, what is that called? Okay, what is this part of the quadratic formula called? It is called the discriminant. So if the discriminant, B squared minus 4 times A times C, is greater, I just figured out how to spell greater, is greater than 0, then there will be two real solutions. Okay? So if the discriminant is greater than 0, that means you're going to have two real solutions. What does that mean? That means that the equation will have two answers, and the two answers will be real numbers. Okay? So if b squared minus 4ac is equal to 0, so if it equals 0, then there will be one real solution. Okay? So if the b squared part, minus 4 times ac, the discriminant, if it turns out to be equal to 0, then what that tells us is that my solution, there's only going to be one solution to the problem, and that solution is going to be a real number, like a normal number that you're used to seeing. Okay, so then there's a third option that says if b squared minus 4 times ac is less than 0. So if this discriminant turns out to be less than 0, then there will be imaginary solutions. Okay? Imaginary solutions. There we go. So this is what the discriminant, it gives us a clue. It gives us a clue if there's going to be two real solutions, if my equation is going to have two real answers, and that would be if the discriminant is greater than 0. If the discriminant b squared minus 4 times ac is equal to 0, then there will be just one real solution. And if the discriminant b squared minus 4ac is less than 0, then that's going to tell us there will be imaginary solutions. Okay? And if I wanted to rewrite this without so many words and in just mathematical symbology, I could write it like this. So if b squared minus 4 times a times c greater than 0, okay, this means two real solutions. All right, if b squared minus 4 times a times c is equal to 0, that will mean you're going to have one real solution. Now keep in mind, today we are not going to be finding what the solutions are. We're just going to be finding how many solutions will it be. And then the third one would be if b squared minus 4 times a times c, which is called the discriminant, which is a part of the quadratic formula, is less than 0, then that means we're going to have imaginary solutions in our problem. Okay, so let's, as they sang in The Lion King, let's get down to business, and let's do a couple examples where we're using the discriminant here. Okay, so in this problem, here's what we're going to do. We are going to find the discriminant's value. Okay, so that's the first thing that we're going to do. Secondly, we're going to state how many solutions the equation will have. We're not going to find the solutions. We're just going to state how, whoops, I left out the word many, how many solutions the equation will have. Okay? And then thirdly, then we're going to look at the graph of the equation. Okay? Look at the graph of the equation. All right, so here we go, you guys. Let's go through this here and let's do these 3 steps. So the example number, we'll call it A. So example A. X squared plus 6x plus 4 is equal to 0. So x squared plus 6x plus 4 is equal to 0. Notice, what is the largest exponent you see? It's a 2. So this is a quadratic equation. We are going to look at the discriminant. Okay? So once again, what is the discriminant? So we need to, first of all, we need to find the discriminant's value. So the discriminant, I'm going to make a column right here, I guess. So the discriminant is that part of the quadratic equation, which is b to the second power minus 4 times a times c. Okay, so now let's go to the equation and let's determine the a value, the b value, and the c value of this equation. So if you recall, the a value is the coefficient in front of the x squared. The b value is the coefficient or the number in front of the x. And the c value is the number that has no variable next to it, an x or an x squared. So in this case, what would my a value be? My a value would be 1. If there's no number that you see, it's a 1, it's implied. My b value would be positive 6, so 6. And my c value would be positive 4, so we could write 4. Okay, so the first thing you have to do when we're finding the discriminant value, you have to determine the a value, the b value, and the c value, and you get that from looking at this equation, this quadratic equation in standard form. Now, to find the value, we're going to plug these numbers, substitute these numbers into this formula right here, which is the formula called the discriminant. So in the place of b, I'm going to put a 6, so I'm going to have 6 squared minus 4 times, in the place of a, I substitute a 1, times, and in the place of c, I substitute a 4, and then I follow my order of operations to figure this out. So do the exponent first. 6 to the second power is 36, minus 4 times 1 times 4. Then do not subtract, multiply these three numbers out. So go 4 times 1 times 4. 4 times 1 is 4. 4 times 4 is 16. So now we get 36 minus 16. Okay, and then you subtract, so we get 20. So in step number 1, where it said find the discriminant value of this quadratic equation would be 20. Okay, step number 2 is state how many solutions the equation will have. Okay, so what we do with that is we go back to our notes here, and I'm going to show you my notes here in a second. And here's my notes. Yeah, you can see them. So the question is the discriminant, is it greater than 0, equal to 0, or less than 0? Well, it's 20. That's greater than 0. So how many solutions will there be? There will be 2 real solutions. Okay, so let's go over here. So we have the discriminant. Then we're going to have number of solutions. And we're not finding the solutions. The solution to this quadratic equation is not 20, but we're going to have 2 real solutions. Okay, how do we know we have 2 real solutions? Once again, because if the discriminant is greater than 0, it's 20, that's greater than 0, then there will be 2 real solutions. Okay, and then the third step, let's look at a graph here. All right, so I'm just going to sketch out the graph. I have worked ahead of time, and I'm not going to lie, I actually went to desmos.com, and so I went to this website right here, which is a very good graphing website, which you guys are very familiar with, and I actually pre-sketched out the graph. Okay, and this is what, if I were to graph x squared plus 6x plus 4, this is what the graph would more or less look like. It would be a parabola, and it would more or less look like that. Okay, so that right there is the graph to x squared plus 6x plus 4. And there's something that I want you to notice is that when I look at the x-axis, how many places does, or how many spots does this parabola intercept the x-axis at? You could see it has 2 x-intercepts. Okay, so notice right there we have 2 x-intercepts. Okay, we were told that we were going to have 2 real solutions. How did we know there were 2 real solutions? Because the discriminant was 20, which was greater than 0. All right, let's do another one here. Let's do b. Okay, we're going to do the same thing. So equation b is x squared minus 5x minus 34 is equal to 0. We are going to find the discriminant's value in this problem. So once again, the discriminant is the part of the quadratic formula, b squared minus 4 times a times c. Okay, so what's the a value? Well, remember the a value is going to be the number in front of the x squared. The b value is going to be the number in front of the x, the coefficient in front of the x. And then the c value is going to be what we call the constant, which is going to be the value that has no variable next to it. So in this particular equation, a is equal to 1, b is equal to negative 5, and c is equal to minus 34, so negative 34. So to find the value of the discriminant, we're going to substitute in these values. So in the place of b, substitute a negative 5, so we get negative 5 squared minus 4 times a, we substitute 1, times c, we substitute negative 34, and then we evaluate this expression following the order of operations. Okay, the first order is you go ahead and use the exponent. So negative 5 to the second power is positive 25. So we're going to get positive 25 minus 4 times 1 times negative 34. The next thing we do is do not subtract 25 minus 4. You have to multiply these three numbers out first because you multiply before you subtract. So 4 times 1 is 4. 4 times negative 34 is negative 136. Now here's where you have to be careful. So this becomes 25 minus negative 136. Don't just put minus 136. You already have a minus sign there. And then 4 times 1 times negative 34 is negative 136, which means we're adding here, which really means we're just going 25 plus 136, which is equal to 161. So find the discriminant's value. In example B, the discriminant's value is 161. Okay, next we're going to find out how many solutions this has. So because the discriminant's value was 161, because 161 is greater than 0, that means we're going to have two real solutions. Okay, so this means we're going to have two real solutions to this equation. I don't know what the solutions are yet. That's going to be for next week, but we do know that there's going to be two of them. Okay, and then the last thing is, let's just take a look at a graph here so you guys start seeing like a connection. So once again, I already graphed this graph ahead of time, and this graph, if I were to graph it, would look more or less like this. This is a sketch of the graph. I already did it on Desmos. So if I were to graph the equation x squared minus 5x minus 34, that's what it would more or less look like. That would be a parabola. And once again, how many x-intercepts? Notice this graph has 1, 2 x-intercepts. Okay, 2 x-intercepts. The discriminant told me we were going to have two real solutions. We have 2 x-intercepts. So what do you think this number, when we say it has two real solutions, what do you think that's actually telling you in terms of your graph? Hopefully you're starting to see that connection. Okay, all right, let's do another one. C here. Okay, so here we have C. So C's equation is going to be 2x squared minus 3x plus 2 is equal to 0. First thing we're going to do is we're going to find the discriminant's value. So once again, the discriminant is the part of the quadratic formula, which is b squared minus 4 times a times c. We're going to go over to my equation. There's my value of a, there's my value of b, there's my value of c. So a is equal to 2. My b value is negative 3 because it's a minus 3, so negative 3. And my c value is plus 2, so I put a 2. I'm going to substitute those values into my formula, which is the discriminant. So in the place of b, substitute a negative 3, so I get negative 3 to the second power, minus 4 times A, substitute 2, times C, substitute 2, and then we're going to evaluate this expression by following the order of operations. Do the exponent first. Negative 3 to the second power is 9, so I get 9 minus 4 times 2 times 2. Once again, I've warned you, do not go 9 minus 4. You have to multiply these numbers out. The order of operations say multiply first, so 4 times 2 is 8. 8 times 2 is 16. So now my discriminant becomes 9 minus 16, which is negative 7. Okay, so in this third example, example C, my discriminant turns out to be negative 7. So what does that tell me about my solutions when my discriminant is negative 7? You can see right here, if b squared minus 4ac, the discriminant, is less than 0, negative 7 is less than 0, there will be imaginary solutions. So this tells me that I'm going to have imaginary solutions to this equation. So that means next week when I work this equation out and I actually find out the answer or the answers will be imaginary solutions. Okay, so what does that mean? It means that we're going to have that imaginary number I involved in it. Looking at the graph of this, and once again I've already graphed this ahead of time, this graph of this equation would more or less look like this parabola right here. Okay, so if I were to graph, when I graph 2x squared minus 3x plus 2, that is the parabola that equation makes. Now, if you notice, how many x-intercepts does this parabola have? Notice that this parabola has no x-intercepts. So, we knew we were going to have imaginary solutions, and the graph had no x-intercepts. So what does that mean? Well, it means that when your discriminant is a negative number, smaller than 0, it means you're going to have imaginary solutions, and that means your graph won't cross the x-axis at all. You'll have no x-intercepts. Okay, one more, and then we'll call it a day. So here we have D. 9x squared plus 24x plus 16 is equal to 0. So the first thing that we're going to do in this equation is we're going to determine the value of the discriminant. So remember, the discriminant is a part of the quadratic formula. It is the b squared minus 4 times a times c, part of the quadratic formula. It tells us how many solutions this equation is going to have. So what's my a value? It's 9. What's my b value? Positive 24. My c value would be positive 16. Let's substitute those numbers into the discriminant formula. In the place of b, substitute 24. So we're going to have 24 to the second power minus 4 times the a value, which we're going to substitute as 9, times the c value, which we're going to substitute as 16. And then we're going to evaluate this expression following the order of operations. Do the exponent first. 24 to the second power is 576. So this expression, this discriminant, becomes 576 minus 4 times 9 times 16. Okay, multiply the 4 times the 9 times the 16 out. 4 times 9 is 36. 36 times 16 is 576. So I get 576 minus 576, that is 0. So the discriminant's value is 0. So what does that tell me? How many solutions will I have? Okay, we go back here. If your discriminant, b squared minus 4 times a times c, is equal to 0, there's going to be one real solution. So this tells me that we're going to have one real solution. So next week, when you solve this equation, there will only be one answer to the equation. Okay, that's what the discriminant does. It kind of gives you a clue as to how many answers or how many solutions there are to the equation. It also tells you something about the graph. So once again, I have graphed this equation ahead of time, and this is more or less, this is a sketch of what this parabola would look like. Kind of looks like that right there. So if I were to graph 9x squared plus 24x plus 16, that's what the graph of that equation would look like. And if you notice, how many times does this parabola intercept the x-axis at? Well, you could see this has one x-intercept. So the discriminant was equal to 0. That told us we're only going to have one answer, one real solution to this equation, and when I graph it, it only had one x-intercept. So when I'm saying there's one real solution, what am I saying? I'm saying this graph is only going to intercept the x-axis once. Okay? All right, there we go.